Hello and welcome to the second video on November 2018's higher tier Edexcel maths papers. So I'm going to talk you through all the questions here again, and sometimes I'll go through more than one way of tackling the question in case I think there's more than one main method which may be of benefit to people. So I'm not going to dwell on the niceties, let's just get straight in and try some questions. So let's have a look first of all, of course, at question 1. So we've got a Venn diagram for question 1. So E, curly E, which stands for everything, is all the even numbers between 1 and 25. So what I would suggest we do first and foremost is just to write down everything inside this Venn diagram. So everything even between 1 and 25 is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 and 24. So we're told what to put in these diagrams. So first what we need to do is consider that some of these regions are overlapping. Okay, so for example, let's think about which numbers appear in both A, B and C. So in A, B and C we've got 8, because you can see 8 exists in both A, B and C. So for this 8, we put 8 in the middle here because 8 appears in each region. So because of that, we can now cross off 8 because we included 8 in the right place. So let's just scrub off 8, then we can move on and think about the rest. So next, let's have a look at this 2. So we've got 2 here in A, but does 2 appear anywhere else? Well, it's not in B or C, so we just put 2 in A, so we can cross off 2. 8 we've done. Then 10, does it appear anywhere else apart from in A? Not in B or C, so we can include 10 in A like so, then cross off 10. Then we've got 14. 14 here in A isn't in B or C, so we can just put 14 in A and cross off 14. Next for B. So B, we've got 6. 6 doesn't appear in A or B, so here we can just put 6 in B only. So put 6 down, cross 6 off our original list. Then we've got 8, which we already got from before, and 20. You can see 20 actually isn't just in B, but 20 is also in C. So 20 we put where B and C overlap, which is this part here, and then we've done for B. So let's cross out 20 like so. Finally, looking at C, we've got 8 already from before. 18, does that appear anywhere else apart from in C? No, it doesn't. So we can just write down 18 for C. Cross it off our list. 20, well, we already had 20 from before. And then 22 only appears in C, so we can write 22 in and then cross it off here. Now, as you can see, there's some numbers that haven't been included. So we've got 4, 12, 16 and 24. So these numbers that haven't yet been included anywhere, 4, 12, 16 and 24, go anywhere on the outside of the circles but inside the rectangle. So 4, I was going to put 6, that's wrong, 12, 16 and 24 like so. So that's part A done. We've completed the Venn diagram. So next we need to be thinking about part B. So numbers chosen at random from the Venn diagram. Find the probability that the number is a member of A intersection B. This means A and B, essentially. So A and B means where A overlaps with B. And so the overlap of A and B actually occurs in this part here I'm colouring in. Okay, so there's only one number in that there's an even number 8. So therefore the probability if a number is in the intersection of A and B is just for one number, which is 8, out of a total number of numbers. So how many numbers are there? How many even numbers are there between 1 and 25? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we put down 1/12, and then we've done. So that's question 1 done. Let's now have a look at question number 2. Question 2, we've got a scatter graph here. So Sean's got information about the height in centimetres and the weight in kilograms of each of 10 rugby players. He's asked to draw a scatter graph and align a best fit of his information, and here is his answer. So it says he's plotted the points accurately, so that's not the issue. What other two things are wrong with his answer? So there's a couple of things to spot here. If we look at this linear scale at the bottom, I say it's linear, it should be linear. The numbers should be going up in even gaps. So for example, 160, 170, 180, 190, 200, they're going up in tens. But here, from 140 to 160, that goes up in a 20. So that's wrong. Because if it's going up in 20s, the next one should be 180 and 200 and so on. So it goes up in a 20, then a 10, and that's not allowed for a scatter graph because for scale, it changes halfway through. So for this one here, just to illustrate, that's a gap of 20 which is wrong. It should be a gap of 10. So we could word this in a few ways, but probably the easiest is to say this. So the x-axis, which is the heights, does not increase linearly. Another way you could say, in brackets, like I've said, 150 is missing. If we're going up in tens, we should be starting at 150. The second thing to notice is this line of best fit. A line of best fit should go pretty close to most points. Here, he seems to have tried to get it to go through this starting point where the axes meet, and that's not what you have to do. The line of best fit should be somewhere going much steeper and closer to the points. In fact, it should be something like this. So that's what it's got in yellow, and it should be something like this red one instead. So obviously this red one's much closer to most of the points. The other one he's drawn isn't very good at all. So we just make a comment on the line of best fit not being very good. Something like this will do. The line of best fit does not run close to enough of the plotted points. Down here, for example, it's miles away from these two. So that line of best fit is just not very good. So the x-axis doesn't increase linearly, and the second point, line of best fit, isn't close to enough points. Question 3, we have a triangle BEG. A, B, C and D, E, F are parallel lines. Work out the size of x and give a reason for each stage of your working. So here what we need to do is we need to remember the laws for angles on parallel lines, and we can start, to be honest, wherever we want. So what I'm going to have a look at here is thinking about what we can add in, what we don't already know. So we're told DEF is parallel to ABC, and DEF is therefore a straight line in its own regard. We know that angles on a straight line add up to 180, so we can work out this one. So this angle here is BEG. So let's write down what BEG is. So BEG must be 180 minus 110 minus 25. And if it's a calculator exam, don't even risk miscalculating. Let's just do this here. So 180 minus 110 minus 25 gives us 45 degrees. And the question does say to give a reason for each stage. So the reason we know that BEG is 45 degrees is that angles on a straight line add up to 180. So that's one thing we can do. So BEG is 45 degrees, like I've just drawn in here. So what can we also work out next? Well, another angle law you should be familiar with is angles which are co-interior. So if I have a look at from D to E, and then from E up to B, and from B going to A, we need to know that co-interior angles will always add up to 180 degrees on parallel lines, this is. So because that's 110, this angle here has to be 70 degrees. And again, we can write this in with a reason. This angle here is ABE. So ABE is 180 minus 110, which is 70 degrees. And we can give a reason for that. That's because co-interior angles add up to 180 degrees. So I'm just going to colour code that one as well. So ABE colour is 70 for that reason that I've just mentioned. Our target is X, so we're getting closer to X. And again, using this idea of angles on a straight line adding up to 180, we can now work out this angle at the top, which is angle EBG. So EBG, again because angles on a straight line add to 180, EBG will be 180 minus the two angles either side of it, because this one, EBG, and the 35 degrees are all on the same side of a straight line. So 180 minus 70 minus 35, and again I'd recommend using a calculator. That gives us 75 degrees. And again we can say why. It's because angles on a straight line add to 180. And one more step and we're done. So again, I'm just going to put down here that that's 75 degrees. Now finally, we can work out X, because X, 75 degrees and 45 degrees are three angles inside the same triangle. And we know that angles in a triangle add up to 180 degrees. So, final step. Therefore, X will be 180 minus 75 minus 45, which weirdly turns out to be exactly 60 degrees. And if you don't believe me, let's just try it. So 180 minus 75 minus 45, we get 60 degrees. And again, just include the reason. That's because angles in a triangle add up to 180. And we're done. So obviously you don't need to colour code it like I am. I just like to colour code it just so hopefully you can see where my values are coming from in relation to what's been labelled on the diagram in question. So that's all done now. So let's now have a look at question 4. Question 4, a banking question. So Northern Bank, which is a fictional bank, have two types of account. Both accounts pay compound interest. So Ali puts £2,000 in the cash savings account. So first of all, I'm just going to highlight that Ali is using the cash savings account. Cash? I mean cash. Whereas Ben is going for the other one. Sorry about before I was on the verge of just coughing there. So Ben invests £1,600 in the shares account. So this is Ben here. work out who will get the most interest at the end of the 3 years. Show all your working. So first of all, let's start with Ali. So in the cash savings account, the interest is 2.5%. So in terms of what we multiply the starting amount by, remember, we always start off with any number with 100% of itself. Percentage interest gets added on. So 100% plus 2.5% gives us 102.5%, and that equals 1.025. And that is the decimal multiplier. That's what we're going to multiply Ali's investment by each and every year the account has that money inside of it. So for Ali, total after 3 years will be what he puts in the account, so 2,000 multiplied by 1.025 to the power 3. So that's what this gives us. So calculators to hand. So 2,000 multiplied by 1.025 cubed. We can round this to the nearest penny, so 2153.78. Now the interest just means how much has been added on. So therefore the interest will be the difference between what he ends up with, which is 2153.78, minus the £2,000 he began with. So the interest is the extra £153 and 78p, which we had here, just ran into the nearest penny. So that's Ali done. We can now compare this with Ben's interest. So Ben only puts £1,600 in the shares account, but he gets a higher amount of interest. So remember, always start with 100%. Ben gets 3.5% interest each year, so add that on. That's the same as 103.5%, which as a decimal multiplier is 1.035. I'll just show you how you can get the calculator to do the hard work for you. So if we put 103.5 shift answer to get the percentage button, then press equals, I'll tell you it's 1.035. So I'm not doing anything clever. The calculator could just tell me that anyway. So now, Ben's total after 3 years will be what he started with, which is the £1,600 multiplied by this decimal multiplier of his to the power 3, because it's 3 years. So let's see what this gives us. So 1,600 multiplied by 1.035 to the power 3, we get 1773.95 to the nearest penny, of course. So therefore, his interest will be the difference between what he ends up with compared to what he started with. So that's going to be 1773.95 minus 1,600, which gives us £173.95p. So now it's just a case of comparing one against the other. So hopefully you can fairly clearly see that Ben's interest is greater. So who will get the most interest? Therefore, Ben will get the most interest. So bearing in mind Ben gets the most interest, and Ben is in the shares account, part B should actually be quite straightforward. So let's have a look at part B. So in the third year, the interest rate for the shares account is changed to 4%. So for the third year, the shares account, which Ben is in, he gets an even better rate of interest on the last year because it goes up from 3.5 to 4%. So does this affect who will get the most interest by the end of the 3 years? Well, we've already worked out from part A, Ben gets the most interest because he's in the shares account. So if this shares account gets an even better rate in the third year, he'll still get the most interest, but the only difference is you'll just get even more interest than what he had before. So it's not going to affect our answer from part A. Ben would still get the most interest, so we can word it something a bit like this. So essentially, the answer is, does it affect? It's a yes or no, it's a no. The reason is Ben, who has a shares account, already gets more interest than Ali. Since Ben's account has given him an even better interest rate in the third year, he would simply just get even more than Ali than what he would have done before. So that's question 4 done. We can now think about having a look at number 5. Question 5, one of these functional maths questions. So it's about painting a floor. So this floor happens to be in the shape of a trapezium. John's going to paint the floor. I don't know if it makes a difference if it's John, Jane or anyone else. Each 5 litre tin of paint costs £16.99 and 1 litre of paint covers an area of 2 square metres. So that's going to be relatively important actually. So we're told about the paint. So each 5 litre tin of paint costs £16.99. So I'll return to that in a moment. Now, because he's going to be painting the floor, what we need to work out is the area of the floor to be painted. In other words, we need to work out the area of this trapezium. Pardon me. And the way we do this is we do the parallel sides added together. Like so. We half that, and then we multiply by this difference, the perpendicular distance in between the 2 parallel sides. So the formula's written in a few different ways by different teachers. You may have seen it as half of a plus b multiplied by h. It's the same thing. So if we work this one out and see what we get, so 10 plus 16, half that, multiplied by 7, gives us 91. So we've got 91 square metres to paint. If each 5 litre tin though costs this, and 1 litre of paint covers an area of 2 square metres, then 5 litres of paint, in other words 1 tin, will cover 5 times as much. Essentially, we're just multiplying this 1 litre covering 2 by 5. If 1 litre covers 2 square metres, then 5 litres will cover 2 times 5, will cover 10 square metres. But of course, we've got 91 square metres to cover. Each tin will cover 10 square metres, so therefore we can work out how many tins of paint are needed. So tins needed will be the 91 square metres divided by 10, Oops, don't know where that came from. So 91 divided by 10, which gives us 9.1 tins needed. Now, unfortunately, you either buy a tin or you don't. You can't buy a fractional number of tins. To the nearest number of tins, you'd round down to 9. But what this is saying is that actually he'll need 9 tins plus an extra bit to finish off. So 9 tins won't quite be enough. So he's going to have to therefore buy 10 tins and have some spare paint that he's not going to use. So he must buy 10 tins. So how much will that cost him? Well, each tin costs $16.99. So therefore, the cost of this will be 10 multiplied by $16.99 for 1 tin, and that's going to go to £169.90. The only trouble is, he's only got £160 to spend. So what he's having to spend is actually more than what he's got. So ultimately the question, does he have enough money? He doesn't. He's £9.90 short. So ultimately, no. John does not have enough money. So you need to borrow almost an extra tenner from somebody. Oh well, John, better luck next time, eh? Let's have a look at question 6. Bit of coordinate geometry now. Get some coordinates. So we've got A, 5, 9, B, which is D, 15. I'm told the gradient of the line AB is 3. Work out the value of D. Each to their own, but I'd strongly suggest in a question like this, you draw a little sketch diagram out so you can picture what you need to do much better. So coordinates, you're going to need 2 pairs of axes, an X and a Y. So here they come. Now A is 5 and 9, so it's 5 along and 9 up. So you can sort of sketch roughly where A is going to be. So A is going to be, let's say it's about here. So 5 along, 9 up, that's A. Next, for point B, well, we don't really know where this D is, so I'm going to guess it's somewhere along here. But 15 is much further up than 9, so I'm going to put B somewhere around here. So B is D along and 15 up. And we're now told about the gradient as we move from A to B. So the gradient of this line, we're told, is 3. Okay, so from this A to that B, for every 1 we go along, we're going 3 up. So next, let's just remind ourselves what the gradient is and how it's calculated. Well, the gradient, all it means is the change in y divided by the change in x. So between A and B, we're going from 9 up to 15. So that's an increase of 6. So the change in y is 6, whereas as we move from 5 to D, the change is the bigger or the final minus the initial. So that will be D minus 5. So the change in x will be D minus 5. So we're told that the gradient is 3, so we can just plug in these values. So 3 equals the change in y, which is 6, divided by the change in x, which is D minus 5. So what we can do now is we can solve this equation by either multiplying by both sides by D minus 5, or by just thinking that 3, how do I get 3 from 6? What do I divide 6 by to get 3? I'd have to do 6 divided by 2. So I could see that D minus 5 would have to be 2 here. So I'm going to show you one way of doing it. Okay. We know that 6 divided by 2 is 3. So therefore we can deduce that this d minus 5 would have to be 2. D minus 5 equals 2. Therefore, D would have to be 7. Now, if you don't like that way, it's okay. I'm going to start here with 3 equals 6 over D minus 5. So, if we just multiply both sides by D minus 5, doing this as a more standard approach, so multiplying both sides by D minus 5. On the left, I'd get 3 lots of D minus 5 equals 6. I can then divide both sides by 3. And if I do that, I'm just left with D minus 5 on the left. So I'm going to get D minus 5 equals 6 divided by 3. 6 divided by 3 is 2. Then finally, if I add 5 to both sides, again, I'll see that D will be 2 add 5, which is 7. But both approaches, I think, hinge on doing a nicely labelled sketch diagram so we can see where to go and what to do. Question 7. Write the number 0.00008623 in standard form. Okay, a number in standard form means the first bit, if I want the number to be in between 1 and 10, I want it to have only one non-zero digit before the decimal. So I want it to be here. That's why I want my decimal in between the 8 and the 6. At the moment, the decimal is actually there. So I want that decimal to move 1, 2, 3, 4, 5 places over. And if it did move 5 places over, it'd be 8.623. But remember, I always need this multiplied by 10. Now, if it's a small number, 0.000 something, it's going to be a minus. To get the decimal from where it currently is to where it needs to be, I've moved 5 places, so therefore it's minus 5. Another way we can see this is if it's a small number, which we need to write in standard form, we just simply count how many zeros in total, including this 0, are before the first non-zero number. And here we can see there's 1, 2, 3, 4, 5 zeros. Hence, we write 8.623, and because of these 5 zeros, we put minus 5. I can also show you a little trick, a hack, if you like, how your calculator can do the hard work as a third approach. So for this, what we do is we get the calculator and we press Shift menu. You'll notice here you've got number format, so press 3 for number format. Now standard form is a mode often used in science and by scientists, so we're going to press 2, which is code for standard form. So press 2, then here it says select 0 to 9. That means how many significant figures you want to have in your final answer. If in doubt, just put 9, and then you can ignore the trailing zeros at the end. So put 9. Okay. Now we just type in the number as it is, and press equals, and the calculator will do the hard work for us. So we're going to put 0.0000, sorry, double press there, 8623. Press equals, and you can see here we get 8.623 times 10 to the minus 5. So as long as you have the gumption to know that these trailing zeros can be scrubbed off, then this answer, scrub off those zeros, is the same as what we got here by manually considering how many places we move a decimal back. I'm going to leave the calculator in this mode because it's very useful for part B as well. So part B, it says work out this calculation and give your answer in standard form correct to 3 significant figures. Okay, so I'm just going to show you how to do this purely based on the calculator. Okay, so press the calculator. So go to Shift menu again, number format, press 3, go to SCI. Now here, we're told how many significant figures we want the answer to be in. It's 3 significant figures, so press 3 here. Now just type it in exactly how it looks in the question. So at the top we've got 3.2. This button here is a standard form button, but I personally prefer typing it in manually. So just do times 10 to the power 3 and plus 5.1 times 10. Press the power button, then minus 2. Toggle down, then type 4.3 times 10. Power button, minus 4. Double check what you've written is the same as what the question says. That looks pretty much exact to me. So we're good to go. Press equals, and there you have it. 7.44 multiplied by 10 to the power 6. And even better than that, the calculator's told us we've got 1, 2, 3 significant figures. So we're all done, good as gold. Before I move on to the next question, I'm just going to show you how to reset your calculator back to normal mode. Press Shift menu, number format, press 3. I want to go back to normal mode, so press 3 for normal. And for some reason, normal mode 2, I believe, is better, so press 2, normal mode version 2. And you're back to normal. So that's how you do question 7, and that's how, one of many ways, in fact, the calculator can be incredibly useful on the calculator exams paper 2 and paper 3 as well. Question 8. We're talking about transformations of shapes on the coordinate grid. So triangle P is reflected first of all in the line y equals minus x to give Q. So let's just do this step by step. So let's just first of all find how P is going to move to Q. So let's consider this. So it's reflected in the line y equals minus x. So first of all, we need to draw that line in. We should know that the line y equals minus x goes through the origin and is perfectly diagonal from corner to corner going downwards. So it's going to be this line here I've drawn in. When we reflect points, each point ends up being exactly the same distance away on the other side of the line of reflection as what it ended up, as what it originally was. So let's just think about each point step by step. So this point here, direct distance from the mirror line is only 1 square away diagonally. So it'll end up being 1 square diagonally away on the other side. So this point here maps to this point. Next, considering the right angle. So this right angle here is 1, 2, 3 squares away. So when it's reflected, it'll be 1, 2, 3 away from the mirror line. It will end up down here, like so. Finally, this point at the top, in green, that's 1, 2, 3, 4 squares away. So again, once it's reflected, it will be 1, 2, 3, 4 away. It'll end up down here, like so. Then we just connect the points to make triangle Q. So triangle Q is here. Next, triangle Q is reflected in the line x equals minus 1 to give triangle R. So the line x equals minus 1 is going to be a vertical line cutting the x-axis at minus 1, like so. And again, each point is just going to end up the same distance around the other side of the mirror line than what it began with. So the top point here is 2 squares away from this line x equals minus 1. Once it's been reflected, it'll be 2 squares around the other side. It'll be here, like so. This bottom point here will be just directly beneath the red one, like so. And finally, this green one is 1, 2, 3, 4 squares away. So it'll end up being 1, 2, 3, 4 squares away here on the other side. Finally, we're just drawing up these 3 points to work out where triangle R is, like so. So that's where triangle R actually ends up. So we've gone from P to Q to R. Next, it says to describe fully the single transformation that maps triangle R to triangle P. Well, just by looking here, we can't get from P to R by a reflection. There's no way I could reflect P to end up with R. So it's not a reflection, so we can rule out a reflection. Has it got bigger or smaller? Is it an enlargement? Well, it's exactly the same size. It's not got any bigger or smaller, so we can rule out enlargement. Is it the same way round? It's not been, moved or rotated. Is it just a translation? Is it just moved and nothing else? Well, obviously not, because here it's a different way round at R. So the only thing left to say, we can deduce it must be a rotation. So we get 1 mark for saying it's a rotation, but we need to think about how far in terms of degrees rotation is, and also the centre of rotation too. And apart from taking the perpendicular bisectors of the 2 lines joining 2 different points, which is very technical, your teacher may have mentioned this, the best thing I would say is to get some tracing paper and do some good old-fashioned trial and improvement. So I've traced around P here, and I'm going to guess, I think I'm going to go for the origin as my first guess. So with tracing paper, hold down your tracing paper firmly with a pen, pencil or compass point, hold down the centre of rotation on that point, rotate around it. So a sharp object, I'm going to get my compass needle here, plonk it when rotating around, and let's see if I land up on R if I rotate it about the origin. Oh, I've missed R sadly. That's too far to the right hand side. So maybe I need to try over here next. So let's try a different point. The origin didn't work. Let's see if it's over here. Okay, so again, get the compass needle, pop it on there, and see what happens. Well, that's a bit better. It's closer. I'm getting close to R, but I'm still a bit low down. So that's closer, but I'm a bit low down. So next I'm going to try going 1 square up and seeing if that works here. So I'm going to try -1, 1 next. Okay, so finally I'm going to get my compass needle. I pop it there. I'm going to see if this works. So I'm going to do a 1/4 turn like I have done before. And what do you know? It fits. So we've cracked it. So we've worked out the centre of rotation, which is -1, 1. So we just fill in these details. So describe fully the single transformation. It's a rotation. We say that first of all. Now, how much turn did we give it? Well, we've turned from here, and we did a 1/4 of a turn to end up there. So it's a 90-degree rotation, and we turned it clockwise. And finally, give the centre of rotation the centre of rotation is here. It's -1, 1. So quite a tricky question, but hopefully that illustrates how you could attempt such questions in the future. So let's now have a look at the next one. Question 9. Martin truncates the number n to 1 digit. So essentially truncates means cuts it off. So he leaves just 1 digit left of it. The result is 7. So write down the error interval for n. So here we just kept with the first digit and it ends up being a 7. So it could have been a 7, it could be like 7.1, 7.578. It could be 7 point anything pretty much, but it can't have begun with 8. It could be 7.9999 for almost as long as you like. So what we say here is that n, obviously it's 7 point something, but it must have been less than 8. Because if n were 8, and he cut it off to the first digit, we would have been left with an 8, not a 7. And so we can just leave it like that. So it's a quick question. It's about the concept, which is the hardest thing. So the error interval for n is greater than or equal to 7, but must be less than 8. Question 10. Again, we're talking about paint, strangely enough, like we talked about earlier. So Robert's making 50 litres of green paint by mixing litres of yellow paint and litres of blue paint in the ratio 2:3. Now, he's not painting a floor. This time he's just mixing paint, unlike question 5. So yellow paint is sold in 5 litre tins, and each tin of yellow paint costs £26. Blue paint, however, is sold in 10 litre tins, and each tin of blue costs £48. What he's going to do, he's going to sell all of the green paint he makes in 10 litre tins. He sells each tin of green paint for £66.96. Work out Robert's percentage profit on each green tin of paint he sells. So we need to just consider this, I would say, as a ratio. So here's a little table which can scaffold building up the question in terms of getting to the final answer. So we can think of this as yellow paint, blue paint, and total. Importantly, the yellow and blue needs to be combined in this ratio of 2:3. And so we can't get away from this. It needs to be in the ratio 2:3. So we notice here as well, yellow paint is sold in 5 litre tins and blue in 10 litres. So what combination of numbers of yellow paint tins and blue paint tins would give us a ratio which is equivalent to 2:3? Well, let's just consider this building up. So first we've got yellow paint. So yellow paint comes in 5 litre tins. So when he buys tins of yellow, this is going to be in multiples of 5. So we'd have 5, 10, 15, 20, and so on. Whereas for blue, comes in 10 litre tins. So that'll be 10, 20, 30, and so on, in multiples of 10. So if you notice here, if he had 20 litres of yellow and 30 litres of blue, pardon me, that would be 20:30, which would simplify down to 2:3 as required. So that said, he could get 20 litres of yellow paint and 30 litres of blue. And I'm going to put in brackets how many tins this is. So 20 litres of yellow would be 4 tins. 30 litres of blue would be 3 tins of blue. In total, that would make him 50 litres of paint. But here, the main thing we're talking about is actually cost. So if he were to buy 4 tins of yellow, and yellow's costs £26 per tin, the cost of 4 tins of yellow would be 4 multiplied by 26, which comes out to be £104. And 3 tins of blue would cost 3 times £48, which is £144. So the total cost of those 50 litres of paint, the 4 tins of yellow mixed with the 3 tins of blue, would be 104 plus 144, which is £248 for 50 litres. But of course we're told here he's planning on selling them in 10 litre tins. So if it costs £248 for him to make 50 litres, we could divide that by 5 to work out the cost it will take him to make just 10 litres of paint he's selling. So per 10 litres, we can do 248 divided by 5. So 248 divided by 5, that gives us 49.6, which is £49.60. So each tin of green will cost him £49.60 to make. So I'm going to highlight this here. So each tin of green paint costs £49.60, but he sells each tin of green for £66.96. So I'm going to write this down. So each tin of green, that costs Robert £49.60 to make, but he's going to sell it for £66.96. So from this we can work out the profit. So profit per tin is going to be essentially what he sells it at, £66.96, minus the £49.60 it costs him to mix it up and make it himself. So what does that come out as? So £66.96 minus £49.60. That equals £17.36 profit per tin. We want to work out the percentage profit. So for percentage profit, same with percentage change, it's a general formula. Percentage change is the change divided by the original multiplied by 100. In terms of percentage profit, it's the actual profit made as a ratio of the cost, essentially. So it's profit divided by initial cost, and that multiplied by 100. So here it's going to be £17.36, which is the actual profit per tin. We're going to divide that by the cost to make each tin, which we worked out earlier was £49.60. Then we're going to multiply that by 100. So let's see what that gives us. So £17.36 on top, divided by £49.60 on the bottom, and then we're going to multiply that by 100 to convert it into a percentage, and that gives us exactly 35%. So he's making 35% profit each time he makes a sale. So that's not bad going. So well done, Robert. So that's question 10 sorted out. Let's have a look now at number 11. So question 11. In a restaurant, we've got 9 starter dishes, 15 mains and 8 desserts. Janet's going to choose one of the following combinations for her meal. So she might have a starter and a main, or she might have a main and a dessert, or she might even have a starter, a main and a dessert dish. So we need to show now that there are 1,335 different ways to choose the meal. So this is what we're going to do now. So what I've done here, just for the sake of illustrating and thinking about this in real life, I've made up a mock menu. So don't judge me for what foods I've made up. It might not be diverse or even healthy. I'll just thought up some starters, mains and desserts to sort of make a picture of how this question might go. So let's have a look at this. So first of all, let's just consider each thing step by step. So first of all, got starters, 15 mains, 8 desserts. So let's now think about this. What if she chose a starter and a main dish? So first of all, she'll have to choose a starter, and we can see here there's 9 choices for her to make. So these might be the choices. Again, I've made these up, don't judge me. Soup, spring rolls, stuffed mushrooms, etc. The main thing is there's 9 choices. But for each choice for a starter, she then has 15 other choices for the main. So starters and mains combined, you could consider it like this. It'd be a grid, 9 columns for each of the starters, and 15 rows for each mains, which goes with each starter. So in terms of this grid, we've got 9 columns and 15 rows. That's 9 multiplied by 15. So 9 times 15, for the starters and mains, that gives you 135 combinations. Next, what if she picked instead a main dish and a dessert dish? So how would that alter things? So to bring back the mains, she'd have these again to choose from. 15 here, count them if you don't believe me. But now, let's just make up some desserts. So for each of the 15 mains, she'd have 8 desserts to choose, just one of those 8 to go with each main. And here's 8 desserts. I'd personally go for the ice cream, I think. So you've got 15 rows for each main, but each one has got 8 possible choices to go with it. So this is going to be 15 times 8. Here we've got 15 multiplied by 8 possible combinations she could have. And 15 multiplied by 8, that's 120 combinations. Next up, what if she had one of each? What if she splashed out, she had a starter, a main, and a dessert dish? So if you were to do that, we could split this up into 2. So a starter and a main, well, we know this already. So the starter and a main, from before, that's 135 combinations. But then, and, so multiply, she'd then have, with these 135 combinations for the starters and mains, she'd have a choice of 8 different desserts to go with those. So if she had a starter, a main, and a dessert dish, it'd be 9 times 15, 135, multiplied by another 8 for the desserts. So that'd give her a choice of 135 multiplied by 8, which is 1080 choices. That's 1080 combinations. So therefore, total possible choices let's just show the examiner how we're arriving at this. So for the starter and main, that was 9 multiplied by 15. Then for the main plus dessert, that was 15 multiplied by 8. And then finally for the all 3, for the 3-course meal, for the starter, main and dessert, we had 10,080 combinations, and that 1080 comes from multiplying 9 by 15 by 8. And just to double check, you could verify this on the calculator to just make sure it comes to 1,335, just to double check that you've interpreted the question correctly. So if we now do that, just to double check, we can see we've hopefully nailed it. So 9 times 15 plus 15 times 8 plus, if I just move to the other side, 9 times 15 times 8. Don't worry about the bid maths, the calculator will sort that out for you. If it makes you feel more comfortable, you can put the brackets in yourself. And like you can see here, we get 1,335 combinations. So not as intimidating as what it might seem, that question. So just keep your head, picture a menu if you really must, and that's question 11 done. Question 12. So we've got an algebraic fraction multiplied by another algebraic fraction. We need to show that this fraction multiplied by that one can be written in the form ax plus b over cx plus d, where a, b, c, d are integers to be found. So this isn't actually as bad as what it might seem. So if we're multiplying one fraction by another, whether it be algebraic or numeric, we just simply multiply the tops together and multiply the bottoms together. And so this here, we can just simply multiply the tops, which gives us 2x multiplied by 4x squared minus 9, all over the bottom 2 multiplied together. So that's 6x plus 9 multiplied by x squared minus 3x. Now if we notice here, we want to show this, which doesn't involve any x squareds at all, so we need to see if we can factorise these terms in x squared into linear factors, because we want to have no x squareds left. So the trick here, looking at our target, which is this, we need to factorise this further. So at the top, we need to spot a little trick here. So 2x we have to leave as it is. However, this thing, 4x squared minus 9, that's a difference of 2 squares. 4x squared is 2x multiplied by 2x, and also 9 is a square number. So because it's minus 9, in one bracket we put plus 3, and in the other bracket we write minus 3. So the spot here is this is a difference of 2 squares one. Looking here, we've got 6x plus 9. Now here we can factorise out a 3 from this, because 6 and 9 are both multiples of 3. So this we can factorise out a 3, and that'll give us 2x plus 3. And also here, this bracket, there's an x featuring in both terms. This is x multiplied by x, and this is 3 times x. So here we can factorise out an x. So we want x squared, so we take this x and multiply it by another x. And to generate the minus 3x, we take this x and multiply it by a minus 3, like so. This is now fully factorised, so all that's left is to see if we can spot any cancellations on the top and bottom. So here we can see that we've got an x on the top and an x on the bottom, so we can cancel the x on the top and bottom. And as well as that, we can also see we've got 2x plus 3 in brackets on the top and 2x plus 3 in brackets on the bottom, so we can cancel those off too. So next we can rewrite this more simply. So on the top we just got left a 2 multiplied by 2x minus 3, and then on the bottom all that's left now is 3 lots of x minus 3. So we're nearing our target, but we're not there quite yet, because here there's no brackets in what we want to show it as. So the final step is just to expand what we've got in this step. So 2 multiplied by 2x, that gives us 4x, and 2 multiplied by minus 3 gives us minus 6. And finally on the bottom, 3 times x is 3x, and 3 multiplied by minus 3, that gives us minus 9. And then we're done for part A at least. Let's have a look at part B now. Part B, we've got 3 different algebraic fractions, and we need to express it as a single fraction in its simplest form. So what we need to do here is aim for a common denominator. So that's the key to solving this question. So I'm going to write the question out bigger to give myself more space, because this is going to be a bit of a slog in terms of writing, but it's not actually quite as hard as what it may seem. It's just a fairly lengthy-ish process. So we've got 3 different types of denominators here. First of all, we've got the x plus 1, we've got the x minus 2, and we've got an x. So the easiest thing to do would be to multiply each of these 3 fractions by the 2 other denominators which aren't yet included in that particular fraction. So looking at this first fraction here, we can multiply both top and bottom by x minus 2 and this x. So here if we multiply both top and bottom by x, and then also x minus 2. The second fraction, similar idea. On the second fraction, we're going to multiply both top and bottom by x plus 1 and this x. So we're going to times by x on top, and then x plus 1. And the same on the bottom. So multiply by x and x plus 1. Finally, same idea for this last fraction. We can multiply both top and bottom of this 4 over x by x plus 1 and by the x minus 2. Even this is quite a lot of writing for me, but never mind. Hopefully you'll see where these numbers are coming from. That's the main thing I want to get across here by doing this. So, next step. So this fraction here is going to become 3 times x minus 2 on the top. And the common denominator, which will be the same for all of these fractions, will be that times that times that. So it's going to be x times x plus 1 times x minus 2. So then here we're going to have 1 times x, which is just x, times x plus 1. On the bottom, again the same fraction again, so it's going to be x, brackets x plus 1, brackets x minus 2. And finally here, this fraction is going to be minus 4, brackets x plus 1, x minus 2, all over x plus 1, x minus 2. Now we want this in its simplest form, so what we need to aim for here is to see if we can expand these out and simplify them down a bit. So first of all, this here. So can we expand all this out? Well, we can, yes. 3x times x, that's going to give us 3x squared. And 3x times minus 2 gives us minus 6x. The middle one here, x times x gives us x squared. Then x times another 1 is just plus another x. Now this one at the end is going to be the hardest. Okay, so let's just do this step by step. So first of all, x multiplied by x, x times x, that's going to give us, in fact, I'll split this up slightly so you can see where this is coming from. Forget this minus 4, just look here at the x plus 1 and x minus 2. So I'm going to just cover up actually everything else so we can just focus in on this. So imagine it was just this. X times x would give us x squared. X times minus 2 is minus 2x. But then 1 plus x gives us plus x. So minus 2x's plus 1x would give us minus 1x overall. And then here, 1 multiplied by minus 2 gives us minus 2. So we're going to multiply all of this by this minus 4 on the outside. Now importantly, it is a minus 4 because we're subtracting all of this fraction. So far I've done the yellow, but we've done that here, expanded that out. So now here, I'm going to take all of these terms in purple and multiply each one of these three by -4. So x squared multiplied by -4 gives us -4x squared. Minus x multiplied by -4, minus multiplied by minus generates a plus, so that's going to be positive 4x. And then finally, -4 multiplied by -2 gives us positive 8. And all of that is being divided by x, brackets x plus 1, brackets x minus 2. So on the top here, we're just going to have a look to see if there are any cancellations. And fortunately there are. So look at the x squareds here. We've got 3x squared plus an x squared, that gives us 4x squared, but because we're subtracting 4x squared, we're left with no x squareds at all. So all we're going to have is x's and this plus 8. So let's start with the positive x's. So here, we've got 4x plus an x, which is 5x, minus 6x. 5x minus a 6x gives us minus x. And of course that plus 8 there. Now that doesn't cancel with anything on the bottom, so we just leave the bottom as it is, which is x, x plus 1, x minus 2. And we're done. So a bit of a slog, that one, but with a bit of practice, these can be done a bit quicker than what you might be currently. So do keep practicing to get your speed and fluency up, and you'll soon be rattling off questions like this in no time at all. Question 13, we've got here a circle and, importantly, an equilateral triangle. So each side of this triangle is equal. One side of the equilateral triangle is a diameter of the circle. So we can see which one is a diameter just by inspection. So the diameter of the circle, I'm hoping you'll agree, is this one here from end to end. So that's the side which is a diameter. We're also told that the circle has a circumference of 44 centimetres. Well, the circumference is the same as pi multiplied by the diameter of the circle. Okay, so if we plug in these values, we're told that the circumference is 44. So 44 must equal pi multiplied by the diameter of this circle. So therefore the diameter of the circle, in other words also the base of this triangle, which is therefore the length of each side of this triangle because it's equilateral, rearranging this, if we divide both sides by pi, the diameter will be 44 divided by pi, which is, well, let's see. So 44, toggle down, then pi is here, so we press shift, then this standard form button, press equals, and we get 14.00. Now I'm going to give this to all the decimal places on the calculator because this isn't our final answer. I don't want to round too soon because I don't want to have any rounding error. So 14.00. Where's it gone? Oops, wrong calculator. Silly me. Got too many calculators. 14.00, 563. 499. So this side here, 14.00, 563, 499. But I want to work out the area of the triangle. So what I need is its base, which fair enough I've got, but I need to work out its height as well. So what I'm actually needing to do here is to work out the height, and I know it's an equilateral triangle, yeah? So each angle here will be 180 divided by 3. Each angle, each corner is going to be 60 degrees. And because this is 14.00563, I can just half that to work out this bit here, then do a perpendicular to make a right angled triangle from this, which I'm going to show you here. I'm focusing in now on this triangle, where this bottom side is going to be half of 14, because this bottom side is a radius from the middle touching the end, rather than a full diameter. So here, I'm going to be thinking of this triangle. So this base at the bottom will be 14.00 and so on, divided by 2. So divide that by 2, 7.002817-ish. 7.002817. And now you can see I'm running out of space in terms of trying to scrunch everything up in this diagram. So what I'm going to do here, I'm just going to take this and expand it over in the corner. Okay, so the bottom side of this triangle I've gone over in the blue colour has a base of 7.00. This side here is 14.005635 and so on, and that's 60. I can now use right angled trigonometry to work out this side here, which is side H. So how am I going to do that using right angled trigonometry? Because this here is a right angle. Well, we need to remind ourselves of obviously SOHCAHTOA, which I've just got here for you. So we want to work out H, the height, which relative to the angle we know is the opposite side. That's opposite to the angle. So we want to work out O, so I'm going to highlight O because we're interested in working out the opposite side. And in terms of what we know, well, we've got the choice, to be honest. So we know both A, the adjacent side at the bottom, and the hypotenuse. So to be honest, we can use whatever we want. So what I'm going to do here, I'm going to go for using the bottom one here, the 7.002817 job. If the bottom side is the adjacent, like so, I can use tan, because tan is based on knowing the opposite and adjacent, so I'm going to use this one, the tan function. So here, tan 60 equals the opposite, which is the height, divided by the adjacent, which is the 7.002817 business. I multiply both sides by 7.00 and so on. I can see that H equals 7.002817 multiplied by tan 60. So we can do this using the value stored on the calculator. So if you see here, the calculator's got 7.00 stored. So if I press A and S, it's got it already. So I can just multiply that by tan of 60 degrees, and we get 12.129 and so on. So we know the base is 14.00 and so on. We've worked out the height. We can now work out the area of a triangle. So therefore the area of a triangle is a half multiplied by the base, which is 14.00563,499. Only round off at the end. Multiplied by 12.129 ... and let's see what that gives us. So we've got this 12.129 stored in the calculator, like so. So I just need to multiply this by a half and the 14.00563. So times that by a half and multiply by 14.00563,499. Press equals. So now I've got an answer which I can now round. I want this given to 3 significant figures. So I want to keep the first 3 non-zero digits, which are 8, 4, and that 9. That 9 doesn't round up because next to the 9 is only a 3, so we've got 84.9 centimetres squared. And we're done. Question 14. We're sketching a curve, only here this curve is one you might not be very familiar with. This is an exponential function. It's y equals 2 to the power x. Give the coordinates of any points of intersection with the axes. My suggestion here is to do some test points yourself so you can get a feel of what sort of shape this graph is if you're not at all sure. So, give yourself some test coordinates. Just use your calculator to do the hard work for you. So let's start with, say, -5. So when we've got -5, y will be 2 to the power -5, which is 1 over 32. So that's obviously really small. The next one, when x is -4, you can just toggle back now and just type in -4 instead. That's 1 over 16. When it's -3, you'll probably spot a pattern if you haven't done already. Got 1/8. So look at these numbers for halving each time. 32nd, 1/16, 1/8. If you try this on a calculator, 2 to the power -2, you get a quarter. If you try 2 to the power -1, you get a half. If you try this here, you should know that anything to the power 0, what that is. Anything to the power 0 is, yep, it's 1. If you look here, the answers are doubling as we go this way. So as x goes 1, 2, 3, 4, 2, 4, 8, 16, 32. So what we need to do is label the x-axis intercept. It's going to cross the y-axis when y is 1. So let's label this in like so. But obviously as x gets big, if this keeps doubling and doubling, when y doubles, it's going to get really big really quick. So it's going to go something like this, really massive, maybe not quite vertical of course, but really, really massive very quick. So it's going to keep increasing at an ever increasing rate. Whereas here, as x goes more negative, it's going to become an ever decreasing fraction, but it's always going to be a fraction. So the next one, when x is -6, you try it if you don't trust me, it'll be 1/64th, then 1/128th, eventually be getting thousandths and millionths and even billionths, but there'll always be a tiny, tiny fraction left, which is always just a smidgen above 0. So this curve is going to get closer and closer to the x-axis, but never ever quite touching it. So something like that would pick up the marks. If you did just touch the x-axis, they'd let you off for that, I think, but do not, definitely do not go below the x-axis, otherwise you would get marks docked for that. Question 15, equation of a circle. Find the radius of a circle. This is essentially a memory test. It's a small part of a GCSE syllabus. The equation of a circle centered on the origin is just simply x squared plus y squared equals r squared. Okay, so we've got x squared, we've got y squared, so this number at the end is the radius squared. Okay, so r squared is 42.25. So it's just spotting and knowing this little fact. So the radius squared is 42.25. Therefore, the radius of this circle is just the square root of 42.25. So let the calculator do the hard work for you. Square root 42.25, press equals 13 over 2, SROD if you want to, 6.5. So the radius of this circle is 6.5 units. That's all there is to that. It's a little memory test really, nothing else. Just can you remember the standard form of the equation of a circle with a centre at the origin? That's all it is for question 15. Let's now have a look at question 16. So we're told that there are only red counters and blue counters in a particular bag. Joe takes at random a counter from the bag, and the probability that the counter is red is 0.65. So that's the first key bit of information. The probability the counter is red is 0.65. Now importantly, he puts the counter back into the bag. So whatever he picks, whether it be a red or a blue for the first picking, doesn't affect the second picking because he puts it back into the bag. So after the first pick, everything is as it was to begin with. Then Mary comes along and takes a counter from the bag as well. Then again, she puts the counter back into the bag. So what's the probability that Joe and Mary take counters of different colours? Well, there's two ways we could approach this, using a tree diagram or without. So first of all, let's think how we could do this using a tree diagram. So essentially, there are two events. So the first event is of, is of Joe picking a counter. And the second event is where Mary picks a counter. So first of all, Joe comes along. There's two options of what Joe could pick. So the first option is Joe picks a red. The second option is that Joe picks a blue. So the chance of picking a red counter is 0.65. Therefore, the chance of picking a blue counter is 1 minus 0.65. Remember, the sum of all probabilities for any one event add up to 1. So if it's either red or blue, the probability of red plus the probability of blue needs to add up to 1. Therefore, blue is 1 minus 0.65, which is 0.35. Then, the second event is Mary picks a counter. So Mary could either pick a red or a blue. If Joe had picked a red, or if Joe had picked a blue, again, Mary could pick, after this outcome, either a red or a blue. So the chance of Mary picking a red is the same as the chance of Joe picking a red, because all counters were put back as they were. Or if Joe picked a red, she could then pick a blue, which should have a chance of 0.35. Same as Joe had have picked a blue to begin with. Mary could then either pick a red or a blue. Chance of picking red is 0.65, same as it was for Joe, or the chance for picking a blue is 0.35, as it was for Joe. So using this tree diagram, how could they take counters of different colours? Well, there's two main routes we could go. So the first route is that Joe could have picked a red, and then Mary could pick a blue, or Joe could have picked a blue to begin with, then afterwards Mary could have picked a red. So this here is a probability of a red then a blue. Or in probability works as a plus. It's a probability that Joe picked a blue first, then Mary picked a red. So now all we need to do is just work out these probabilities. So probability of red then blue is 0.65 and blue is 0.35. So it would mean Joe picks a red and Mary picks a blue. And often works as a multiplying probability. So we multiply these two together for this first route. Or the second option is Joe picked a blue first. I didn't highlight as I'd hoped, that's the whole thing. So, or Joe could have picked a blue first, which is a 0.35 chance. And multiply, then Mary picked a red, which is a 0.65 chance, which is represented by this green highlighted root at the bottom. So now we've got this, all it remains for us to do is to calculate this with our calculators. So get your calculators in hand. By calculator, I do mean calculator, not your mobile phone. Don't use a smartphone as a shortcut. Get used to using your exam grade calculator. So here, we're going to do 0.65 multiplied by 0.35, and then add on 0.35 multiplied by 0.65. And we get here 0.455. So that's our final result, 0.455. We could have done that without doing a tree diagram, so I'll just explain how the wording relates to the solution. So about a tree diagram, the chance of these taking different colours is simply the probability of blue first and then red, so one way is blue and then red, or so plus the probability of red first and then blue. So it's essentially the same as what we saw with the tree diagram, but we can just think of it without having to rely on that aid, if we like. So blue, like we say, if red is 0.65, that means the probability of blue is 1 minus 0.65, which is 0.35. So this is 0.35, and means multiply, so 0.65, and then chance of it being red and then blue after is 0.65 multiplied by 0.35. The same calculation, just for the values in reverse order. So essentially, two lots of this bracket. And as we got from before, we'd still get 0.455, understandably. Let's have a look at part B. So part B tells us that there are 78 counters in the bag. 78 red counters, I mean to say. 78 red counters in the bag. So how many blue counters are in the bag? So let's think of it this way. We've got 78 red counters, and the probability of picking a red counter is 0.65. Then from these two pieces of information, we can deduce that 65% of the counters, 65% of counters must be red. 0.65 as a percentage is 65%. If someone's got a 65% probability of being picked and each counter is of an equal size, then it stands to reason that 65% of all the counters must be red. So applying words to this gives us this expression. Putting the numbers in, the number of red counters is 78. So therefore, 65% of the counters must be 78. So how do we work out what all of the counters is? 100%. Well, we could work out 1% is first of all. To work out 1%, think what we need to do to 65%. Any number divided by itself gives us 1, so we can divide by 65. If we divide this side of a relation by 65 though, to keep it in balance, we need to divide this over here by 65 too. So if we do that, 78 divided by 65 gives us 1.2. So 1% of the total counters is 1.2. Now we can build up to 100% of the counters. 100% of the counters is going to be the 1% multiplied by 100. And if we do 1.2 and multiply by 100, we get 120 counters. So we're almost there now. So 120 20 counters as the total number. The probability of a counter being red is 0.65. We therefore deduced from part A the probability of a counter being blue is 0.35. So therefore, as a percentage, 0.35 is 35%. So we can say that 35% of the counters are blue. So therefore, the total number of blue counters is going to be 35% of 120, which we can now work out. So 35% of 120 is 0.35 multiply 120, which gives us 42. So therefore, there are 42 blue counters. Question 17. We're told that P and Q are two numbers such that P is greater than Q. So first of all, we're told a couple of things. So we're told here that when you subtract 5 from P and subtract 5 from Q, the answers are in the ratio 5 to 1. So let's just get this organised first. So subtracting 5 from P, and then if we subtract 5 from Q, this bit's mentioned first, and then subtracting 5 from Q is mentioned last. We're told that gives us a ratio of 5 to 1. So we can write this down as a relation. So first of all, subtracting 5 from P means P minus 5. And then subtracting 5 from Q, that would give us Q minus 5. We're told that those answers are in the ratio 5 to 1. Now, because ratios work very much like fractions, we can consider this as being 5 over 1. So the ratio of one to the other, the ratio of this one as a fraction divided by the second, will be the same as the ratio or the result as when we take 5 and divide it by 1. So this is our way in to the question. Because these two values in the same ratio as 5 to 1, then that value divided by this value, P minus 5 divided by Q minus 5, is the same as 5 divided by 1, which of course we know is 5. Now we can cross multiply to get a relationship from these two. So if we multiply P minus 5 by 1, that obviously just gives us P minus 5. But then if we multiply Q minus 5 by 5, well, 5 times Q is 5Q, and 5 multiplied by negative 5 is minus 25. Now, if we now add 5 to both sides of this equation, we can find an expression for P in terms of Q. So we get that P equals 5Q, and then minus 25 plus a 5 gives us minus 20. There's now some extra information on this question. So we're also told here that when we add 20 to P and add 20 to Q, so I'm going to run out of colours very soon. I'll go for pink, I think. These answers are in the ratio of 5 to 2. So using this link from ratio and division, that means if we take this result in green and divide it by this result in pink, it's the same as what we'd get if we did 5 divided by 2. That's because the adding 20 to P is mentioned first, and this 5 is mentioned first. So the adding 20 to P links to the 5, and because this adding 20 to Q is mentioned last, and the 2 is mentioned last, then those two also relate to each other. So from these two, so adding 20 to P So that's 20 add p, all divided by, when we do adding 20 to q, 20 plus q. And we're told that that's the same as the ratio 5 dot dot 2. In other words, this divided by that is the same as 5 divided by 2. So we can do the same as what we did before now. We can cross multiply to again get a relationship between p and q. So if I just cross multiply these two like so, then 20 plus p multiplied by 2. So if we double 20 plus p, we get 40 plus 2p. And here, if we take 20 plus q and multiply all this by 5, well, 5 times 20 is 100, and 5 times q is 5q. If we now try and aim for having p on its own, we can take 40 from both sides, and that will give us 2p equals 100 take 40 is 60 plus 5q. Finally, if we just half both sides of this relation, we'll get p on its own. So 2p divided by 2 obviously just gives us 1p. 60 divided by 2 is 30. And 5q's divided by 2 gives us 2.5q. So now we need to compare what I've highlighted in yellow to what I've highlighted in green. Now, both are equal to p, so what this means is that 5q minus 20 must equal 30 plus 2.5q, because p equals both these things. So therefore what we can say, linking these two together, is therefore 5q minus 20 must equal 30 plus 2.5q. So we can now solve this equation, as long as we take care, and find out what q must be. So how can we do that? Well, what I'd suggest we do is we get the q's on one side and the numbers on the other. So first of all, I'm going to suggest we subtract 2.5q from both sides. So on this side, we'll get 2.5q minus 20 equals 30. Then if we add 20 to both sides, so add 20 here and add 20 over there, pardon me, then we'll get 2.5q equals 50. Then finally, if we divide both sides by 2.5 to just leave us with 1q on its own, then we'll see that q equals 50 divided by 2.5, which is 20. So q equals 20. Next, what we need to do is we need to work out what p must be then. So we've got that q is 20. So I'm going to highlight this. We need to know what q is. We've worked out q is 20. So how can we work out what p might be? Well, we've actually got two equations that relate p and q. So if we now substitute q into this yellow one, we can see that therefore p will equal 5 times q, 5 times 20, minus 20. So I'll just highlight this in yellow so you can see where this is coming from. So 5 times 20, didn't highlight properly again, apologies. So 5 times 20 is 100, and take 20, and that gives us 80. In other words, P is 80, so we know what P is and what Q is. So finally we can answer the question. So therefore the ratio of P to Q, P is 80, Q is 20. Both of these numbers can be divided by 20, which gives us 4 to 1. And that is the final answer. So quite long-winded, but we've got there. That's question 17 done. The ratio of P to Q in its simplest form is 4 to 1. Question 18, talking about straight lines and coordinate geometry. So we mentioned here a straight line L1 and L2, and we've got the coordinates given too. So L1 passes through the points with coordinates 4, 6 and 12 too. My advice would be to just do a simple sketch, diagram of this question. So let's get the coordinate grid up and ready. So add the points in. So we've got 4 and 6. Let's guesstimate where this is on our grid. It's about there, 4 along and 6 up, so it's in the first quadrant, it's in the first corner of the grid. As will 12, 2. So 12, 2 I'm going to highlight in blue. So 12 along and only 2 up, that's going to be lower down and further to the right, somewhere about here. So L1, because it passes through these points, will be a straight line going through the red point and the blue point. So it's going to look like this in purple. Now L2 says it goes through the origin and has got a negative gradient. So L2, which I'm going to do in green, is going to look something a bit like this. And it says that L1 and L2 intersect, in other words they cross over at point P. So where they're crossing here, that's going to be where point P is. Now, all that remains for us to do is to find algebraically what point P will be. Let's first of all consider then the line L1. So for L1, we know 2 points. We know 4, 6 and 12, 2. So we can work out the gradient. The gradient of L1 is the change in y divided by the change in x, as the gradient is for any straight line in fact. So if we look at y, so y has gone from 6 down to 2. So as long as we keep the order of what we're subtracting the same, it will always work out. So I'm going to do this red, take away that blue. So a change in y, I'm going to do 6 subtract 2. And the change in x, I'm going to do 4 subtract 12. Normally I'd say this might be done without a calculator, but because it is a calculator paper, let's just use the calculator so we don't have any chance of making any errors with these negative numbers. So just type in the numbers exactly as they appear. So 6 minus 2, all over 4 minus 12, press equals, and we get minus a half. So therefore L1 is of the form y equals mx. So the gradient is minus a half, so it's minus a half x plus c. So what's the y-axis intercept for L1? Well, we can just substitute in any of these 2 points we know. So I'm going to substitute in 4 and 6. So if we substitute the point 4, 6 into the general equation for L1, we get that y, which is 6, must equal minus a half of what x is. Well, when y is 6, x is 4, so we substitute in 4, then add c. So half of 4 is 2, so minus a half of 4 is minus 2, plus c. If we then add 2 to both sides, we see that c will have to be 8. So therefore, L1 is y equals minus a half x plus 8. L2 is much easier. The y-axis intercept for L2 is 0 because it passes through the origin. So L2 is just simply y equals the gradient multiplied by x. The gradient's minus 3, so L2 is just simply minus 3x. P is where they intersect. Okay, so P is just simply where L1 equals L2. We've got y is a subject for both of these, so we can just simply work out now. We can set minus a half x plus 8, this y for L1, when that's the same as y for L2. So now we can just simply work out when is minus a half x plus 8 equal to minus 3x. In other words, they'll intersect when minus a half x plus 8 equals minus 3x. Now this is a fairly simple equation to rearrange and solve. So if we add x to both sides, so add half an x to both sides, I mean to say, then over here minus 3x's plus half an x, that's going to leave us with minus 2.5x's. So therefore, the x-coordinate where they intersect is 8 divided by minus 2.5. So if we try that, 8 over minus 2.5, that gives us minus 16 over 5. But we don't want just the x value, we want the y-coordinate too, we want the coordinates of P, the x-coordinate and the y-coordinate. So the easiest one to use would be L2. So if we sub x is minus 16 over 5 into L2, so sub x equals minus 16.5 into the equation for L2, which is y equals minus 3x, we'll find what the corresponding y value is. So y equals minus 3 multiplied by minus 16 over 5. Minus multiplied by minus will give us a positive, and that will actually come out at being 48 over 5. So therefore, P has an x-coordinate of minus 16 over 5 and has a y-coordinate of 48 over 5. So those are the coordinates of P. P is minus 16 over 5, 48 over 5. Numero 19. So this looks a beast. So solve 22 is less than m squared plus 7 over 4, which in turn is less than 32. Show all your working. So what to do here? Well, inequalities with 3 different sections, a left, a middle and a right hand side, were the same as equations with just 2 sides. What we do to one end, we need to do to all bits too. What I would suggest we do here, because I don't really like fractions in terms of them not being as easy as whole numbers, I would multiply everything by 4. So times that by 4, times middle bit by 4, and times the end bit by 4. What this will give us is 22 times 4 here, which is 88. Over here we just have m squared plus 7. And at the end, 32 multiplied by 4, that's going to give us 128. Now if we get m squared on its own by taking away 7 from both ends and the middle, we'll now get 81 has to be less than m squared, which has to be less than 121. Now, you should notice that 81 and 121 are both square numbers, but this isn't the easiest thing to get your head around. So what I'm going to do here is I'm going to illustrate this on a graph. So imagine m varying plotted against m squared on the y-axis. Okay, so a graph of m versus m squared would be like this. What this inequality is telling us is that we want m squared, the height, the y-axis, to be more than 81. So imagine this is a height of 81. But also we want it to be less than 121. So we need our height of this graph to be in between these two lines, higher than 81 but lower than 121. And so what this is telling us here is we're looking for this region here and also this region here too. So from here we can actually picture it now. So I want to work out this value of m. Whoops, that is not a straight line, that would bug me. If it bugs you, I'm totally understanding that too. And this one here, I need to work this out too. Whoops, making a mess of this. So I need to work out that one, equally this one, and that one too. So this bit here, between these two bits, relates to I need m to be between these two values, or m to be between these two values. But now, I know that you probably know on a good day, you can tell me if m squared is 81, what two values of m would make that work. The most obvious, the square root of 81 is 9, so over here that could be positive 9, but also minus 9 multiplied by minus 9 would also give us 81, so at this end we have minus 9 here too. This 121, again, like I mentioned, is a square number, so if m squared is at a height of 121, what value of m would make that so? Well, if m squared is 121, then m will be the square root of 121, plus or minus, that is, which is either plus 11 here or minus 11 down there. So I think the graph is a very powerful tool to help us here. So therefore, the two possible ranges of m we have to solve this is that either m is in between minus 11 and minus 9, or m is between 9 and 11. So I do think a diagram makes this 10 times easier, just to picture the numbers and what's going on. That's question 9 done and dusted. Question 20 is a fairly hard question relating density, mass and volume, and also volume, area and linear ratios. So we've got here what's called a frustum of a cone. A frustum is just the bottom bit of a cone if the top bit of a cone was sliced away. So this dotted line and the bottom bit represents the original cone, and the dotted bit is just what's been cut away from the top. So let's think about what this frustum is and how it can be made in relation to the original cone and the small cone that's been cut away. So just to start off with, so we've got this frustum here at the bottom. I'm highlighting in red the original full cone. So the frustum is just this bottom bit I'm going to colour in yellow. And it's made, like it says, by removing a cone of height 3.2 centimetres, this bit here, that's been cut away from the solid cone, which I'm highlighting the outline in red. So what's been removed is this green one. So hopefully you can picture that the volume of the frustum, the base, is just simply the volume of the big overall cone of highlighted in red minus this little cone which has been cut away, if you like. So we can use this volume formula to calculate this. So the big cone, just plugging in the numbers here, the volume of the big cone will be 1/3 pi times its radius squared. Now 7.2 is the diameter of the big cone, so the radius will only be half of that, which will be 3.6. So it's going to be pi times 3.6 squared times the overall height. So if it's 3.2 from end to end, and this bit's 3.2, then the overall height from top to bottom will be 6.4. Now this little cone, we need to apply some proportional reasoning. So this little cone at the top is only 3.2, which is half of the total height of the big cone. If its height is half of the big cone, then its radius will also be half the radius of the big cone. So this one here has a radius of 3.6, half of that is 1.8. So the little cone will have a volume of 1/3 pi times its radius, 1.8 squared, multiplied by its height, which is just 3.2. So if we calculate this, so 1/3 shift standard form button pi times 3.6 squared times 6.4, then minus 1/3 shift pi times 1.8 squared times 3.2, we get here 76.001. So I'm going to write in all the numbers because it can't hurt. This isn't our final answer, so I don't want to round too soon. 76.0014. In fact, I'll leave it like that. I'm in two minds. No, I'll write it fully. Why not? 0948. We're also told that the density of a frustum is 2.4 grams per cubic centimetre. So this relates to a formula we need to know for density, mass and volume, which I'm just going to pop here. Okay, so dmv, in that order is how we need to write it. dmv. So density is mass divided by volume. So because we want to work out the mass, if we cover up mass, we've got density times volume. Therefore, the mass of a frustum will be 2.4 multiplied by the 76.00 whatever. So just take this times by 2.4. We get here 182.4033, so 182.4033. 827 grams. So we now know the volume of the top bit and its mass. So this bit here, we've just worked out its volume and its mass. The question relates to the total shape S, which is going to be a mixture of this frustum and the bottom bit, which, as we can see and read in the question, is hemispherical. It's a hemisphere. It's half a sphere at the bottom. But we've done some of the legwork now. The next thing we need to consider is this hemisphere at the bottom. Okay, so the hemisphere, we need to calculate about this now. I apologise if you think I'm a bit obsessed with colouring in. Maybe I am, but you know, there's worse things in life to be doing than colouring stuff in. And I think it looks nice, so why not? So now we also, fortunately, have been told the volume of a sphere. So from that we can work out the volume of a hemisphere. So if we half 4/3, that gives us 2/3. So it's going to be 2/3 pi r cubed. So we know that the diameter is 7.2. So like before, if we were to half that, what we'll get is 3.6. So the radius of the hemisphere is 3.6. So let's work out its volume and its mass. So the volume of a hemisphere, it's called V subscript hemi to be short and lazy. So we've got 2/3 times pi times its radius, 3.6 cubed. So let's see what this gives us. So 2/3 multiplied by pi times 3.6 cubed. That gives us 97.716 0979. And we're also told the density of it. And as before, mass is density times volume. So the mass of the hemisphere will simply 4.8 multiplied by this 97.7 number. So times by 4.8. And we arrive at 469.037. And the last four digits were 2699. So the reason I write out all the numbers is just to absolutely be perfectly sure that I'm not going to incur any rounding error before I get to my final answer. So now we've got all the ingredients to work out the average density of solid S. So we can now proceed and work out the density of solid S. So based on what we've got here, we can see the density of solid S will be the mass of solid S divided by the volume of solid S. So it's going to be the sum of what we've worked out here. So the mass of the frustum plus the mass of a hemisphere. So 182.40 ... plus the mass of the hemisphere, which is 469.037, and so on, all over the volume. So the total volume with the volume of a frustum plus the volume of a hemisphere, which again we've worked out. So just as the mass of a frustum is 182.40 and so on, and the mass of a hemisphere is this number here, we can do the same thing for the volume of both. So the volume of the frustum is this 76.00 number at the top, and then the volume of the hemisphere is this 97.7 so on number from here. So be careful as we type it into our calculators, and we will get the correct final answer with a bit of care. So the first one, 182.4033.827 plus 469.037 2699, all divided by the total volume, which first of all is going to be 76.00, oops, too many zeros, 140,948, plus the volume of the hemisphere, which is 97.7160979. And what do you know? We get it exactly as 3.75. And don't forget the units. So the units of the overall density will be the same as the units of density used before, which is grams per cubic centimetre. So not the quickest question to attempt, but there you have it. Some questions are tricky. That's why getting these grade 8 and grade 9 questions right does require effort, skill and practice. So there you go, that's question 20 done. Let's now have a look at the final question on the overall entire paper. Here we are, the final question of the entire paper. And what do you know, it's a circle theorems type question, the dreaded circle theorems. So we've got two overlapping circles, and we're told that A, B, R and P are 4 points on a circle with centre O. So this smaller circle, and also A, O, R and C are 4 points on a different circle, this bigger one over here to the left. The two circles intersect at A and R. CPA, so this straight line here, CRB at the bottom, and AOB are all straight lines. So A to B to C makes a triangle, essentially. We need to prove that CAB, this angle at the top, equals angle ABC, this angle at the bottom. So we need to prove that this one is the same as that one. Now this can really stump people, and I can totally understand why. It takes a bit of practice to see these questions, how to tackle them, so I'm just going to highlight it now, what you could maybe spot with a bit of training and taking a step back. So first of all, what we'll need to know today is that angles in a cyclic quadrilateral add up to 180 degrees. So if we've got a quadrilateral where each vertex touches the circumference of the same circle, the opposite angles of that quadrilateral will add up to 180 degrees. So can we spot a cyclic quadrilateral here? Well, actually, yes, we can. If we have a look at this circle on the left, which we're called in yellow and outlined in blue, then hopefully we can spot that from A to O to R to C and back to A is a four-sided shape where all four corners, A, O, R and C, lie on the circumference, like so. So this is indeed a cyclic quadrilateral. So if I now call angle at A here CAB, if I just call that, say, just call it, well, call it angle A really. So angle CAB plus the angle opposite to it, so opposite to angle A is this angle here at R. And that's given by going from O to R to C, or alternatively from C to R to O, whichever you prefer. That equals 180 degrees. And we need to state this circle theorem. So because angles in a cyclic quadrilateral add up to 180 degrees, therefore CAB plus CRO equals 180 degrees. So what we can next spot is this angle here, the other side of R. I'm going to call this angle maybe, I don't know, X. So angle X, which equals ORB, Well, that's going to be 180 degrees minus angle R. It's going to be 180 degrees minus CRO. Okay. Now, we can understand what CRO is from here by rearranging. If we take CAB from both sides here, we can see that CRO will be 180 minus angle CAB. Going back to what I was saying here about angle X and angle R lie on a straight line. So angle X will be 180 degrees minus CRO. And at this point, just to justify our reasoning, we can say here why this is the case. It's because angles on a straight line add up to 180 degrees. So it doesn't hurt to just prove to the examiner that you know exactly what you're doing. So carrying on from here, so 180 minus CRO, well, we've just shown that CRO is 180 minus CAB. So 180 minus CRO is the same as 180 minus 180 minus CAB in brackets. So 180 minus 180 cancels. Then we've got minus CAB, so that equals CAB, like so. So what we've proven here is that this angle A is the same as angle X. Now we need to just shift our attention to the smaller circle. So if I draw attention now to the smaller circle, which I'm going to go over in green, like so, then what can we spot about the two lines here? Well, the centre's O, so O to R, because R's on the circumference, that's a radius of this smaller circle. So I can say this is R, but also from O to B, this from the centre to the circumference as well. So that's also a radius. So therefore, ORB is an isosceles triangle, and we should know that the base angles of an isosceles triangle are equal. And so if this one's X, this one over here will also be X. So ORB, this one here, in fact I'll write that the other way around. So what I'll say here is that this angle at B, so OBR will equal angle ORB. And the reason for that is ORB is an isosceles triangle. And the labelling on here will prove to the examiner that you know that for this reason both these sides are radii. So ORB is an isosceles triangle. So essentially what we're saying here is CAB is the same as ORB, which we proved, and then ORB is the same as OBR. But as well, if we just take a step back and look at OBR, then OBR, this angle in the corner, is also the corner angle in the bigger triangle from A to B to C. So finally we can say, but OBR also equals angle ABC. So what we've proven here is that the angle CAB at the top is equal to angle XORB, which is the same as OBR, which is the same as ABC. So therefore, we can conclude by saying angle CAB equals angle ABC. And that finishes the question and the entire paper. So thank you very much for listening. Some of the questions have no doubt been very hard indeed. Hope this has helped to some degree in terms of understanding them. If not, please do leave me a comment, or in the comment section or ask me in class. I'll try and just clarify further. Thank you again for listening. Please do consider subscribing, and I'll see you all soon, I hope. Take care and stay in touch.